Hey everyone, welcome to the channel Vidyut Yoga. In this video, we will study Ohm's law by using simulation. And for this simulation, we will use the basic electronics virtual lab. Many of the students study Ohm's law theoretically, they solve the numericals based on it. But it will be easy to understand the Ohm's law if we demonstrate it by using the Ohm's law. And that is the main purpose of this video. So before starting the video, first of all, those who are new to this channel, please subscribe the channel. So without wasting time, we'll start the video. The title of the experiment is Study and Simulation of Ohm's Law using the Basic Electronics Virtual Lab. So for that purpose, just go to the Google and search for the virtual lab. So when we search for the virtual lab, then you will get the official website of virtual lab. Just visit to that lab. Then in case of the virtual lab, if you scroll down, there are different laboratories are available. For this experiment, we'll go through the electronics and communication laboratory, under which we'll go to the basic electronics lab. So on left hand side, there are the list of experiments. If we click on this tab, list of experiments, the fourth number experiment is Ohm's law. So just we'll click on the Ohm's law. Then our main purpose is to study the Ohm's law by using this virtual lab. So first of all, we'll go through the theory part. So if we click on the theory, you can go to the theoretical part. But for this video purpose, I am assuming that you are aware about the Ohm's law. Quickly, we'll revise what is the statement of Ohm's law. The Ohm's law states that current through the conductor between 2 points is directly proportional to the voltage across the 2 points. Or we can say that I is directly proportional to the V. Hence, in mathematical form, we can represent I is equal to V upon R. Here, I is current flowing through the conductor, V is potential difference applied across the conductor, and 1 upon R is the proportionality constant, or R is nothing but resistance, which is inversely proportional to the current. So, for the demonstration of this experiment, we know that I is directly proportional to the V, then R is equal to, uh, we write the formula R is equal to V upon I, or you may solve the numericals also based on it. Now, for the simulation purpose, what we'll do, we'll just click on the simulation. You will get the theory also, stepwise procedure also, but I will directly demonstrate it. So we have to study the Ohm's law. So just I will click on the Ohm's law. Then this is the simulation platform is available. Here we'll provide, this is the simple circuit in which resistance is there and DC voltage is applied across the resistor. Ammeter is used connected in series for the measurement of current, and voltmeter is connected in parallel with the resistor for the measurement of voltage. Our main purpose is to understand the Ohm's law, for which we there is need of three parameters: resistance, voltage, and current. So first of all, we'll write down the resistance value for this circuit. Suppose for the resistance purpose, what we'll do, we can adjust the resistance here. Okay. So right now, suppose I will keep this value of resistance, and regarding the DC voltage, you can vary the DC voltage here. So you can see if we vary the value of voltage, accordingly the voltage value as well as current value get changed. So first of all, we adjust the resistance and voltage value, and then we'll go through the reading. Then we'll go to the 3 to 4 readings, and then we'll plot the graph. and that graph will conclude the Ohm's law. So for example, for first reading, I will keep this DC volt at this position. From this um, voltmeter, you will get the idea about the voltage. It is nearly equal to 6 volt. Resistance is adjusted at this value, and I will add the reading to the table. So once I will press on this add to table option, you will get the voltage 6 volt and corresponding current is 0.176 ampere. So you can observe these values also here, and resistance value is 34 kilo ohm. Now I will change the DC volt and resistance value again. So corresponding values are here, like voltage is 10 volt, resistance 48 kilo ohm, and corresponding current is 0.208. But since we have to plot the graph, I will again press to the add to table. So we get the second reading as an observation table. For third reading, I will keep the DC voltage same. I will just change the resistance value so that we can go through the different possibilities. Then again, for the third reading, I will press on add to table. Here is keep the resistance value constant. That is resistance. We can vary the voltage and we can see the relation between current and voltage by maintaining the resistance value same. So I will uh, cha change the DC voltage value. I will enter on the add to table. We get the third value. Similarly, for fourth reading, I will again change the DC voltage. I will add on. I will press on the add to table. And for the last reading, again I will change the DC voltage value. I will press on the add to table. So we get the higher readings. Now theoretically, we have observed from the Ohm's law that current is directly proportional to the voltage. But here, what we'll do, now we have obtained the value of current at a different value of the voltage, and we'll plot the graph. If we press here plot, then it will plot the graph. So I will press on the plot. Then it is observed that this value of current and voltage, it is linear up to this, but after this we have changed the resistance value, and for the same resistance this graph is linear. So what is the Ohm's law? Current is directly proportional to the voltage, but what is the condition? Resistance should remain constant. Here we have changed the resistance value, so we get this graph. Now what we'll do, we'll clear these values, and now for the understanding the Ohm's law, or for pro proving the statement of Ohm's law, what I will do, I will keep the resistance value same, and just I will change the value of DC voltage. So for this value of voltage, I will take the first reading. Now you are having the idea about the uh, how to obtain the values. So resistance value, suppose resistance value is 32 kilo ohm. Now I will press add to table. We get the first reading. I will change the value of voltage. I will obtain the second reading. I will change the value of third voltage. I will get the third reading. With the fourth value of voltage, I get the fourth reading, and with last value of voltage or fifth value of voltage, we'll get the fifth reading. So you can take the multiple readings for the understanding purpose or for the demonstration purpose. I have collected the 5 readings. Now I will plot the graph. Then from the graph, it is observed that this VI characteristic is linear, or current is directly proportional to the voltage. But what is the condition? Resistance should remain constant. So that's from this graph or from this simulation, we proved the Ohm's law. That is, current is directly proportional to the current is directly proportional to the voltage when resistance remain constant. So I hope this video is helpful. You can understand the Ohm's law, or as a mini project, you can demonstrate the Ohm's law by using this uh, video. Then again, those who are new to this channel, please subscribe the channel. Thank you very much.